to be looking at this test review for Unit 1. And we're going to talk through each one. But I've done all the work ahead of time, so I'm going to show you an example, or I'm going to show you the work. I'm going to briefly talk through it, and then this is just a check. If I went through each one in detail, it would take a long time. So this is just a double check, and then you know which ones to ask me about tomorrow before class starts if you do have further questions. But if there's one that you weren't sure how to do, when you get to that point, I would pause the video so you can copy down the right work or rewatch that part or something. Okay, so for number 1G1, I'm pretty sure all of us are going to be good with that. It's just double checking your work. So hopefully you've been checking it as I've been talking. For number 2, I adjusted my graph so it might be a little bit easier. Also notice, like, I broke my graph here so I could start at 110. And then I adjusted my y-scale then to be every box going up to be 0.2. It would just make that slope of 0.2 over 3 a little bit easier to graph. Now, normally when I have you write it in y equals mx plus b, I do have you punch out that to a decimal. But it's easier to maybe plot that 0.2 over 3 than it would be to have 0.067 over 1. So I plotted this one. They're the same line. It's just one simplified a little bit more. Slope 0.2 over 3 means he increases in weight 0.2 pounds every 3 days. The b value means he started at a weight of 110. And then in order to figure out how long he reaches, or until he reaches his weight goal, 125. 125 is a y value here, and that's something I should have indicated. X is days, y is the weight. So they're giving me a y value there. So I'm going to take that y value and plug it into my function for y. Then I subtracted 110 from both sides to get 0.2 over 3x equals 15. And then I divided both sides by 0.2 over 3 to get 225. And that should be 225 days. Okay, flip it. For number 3, that's what your graph should be. I ended up zooming out quite a bit, as you can see from my thing. I think I actually selected zoom, maybe zoom fit. Got me that graph. Key features, there's only 2 of them here. Your y-intercept of 0, negative 12, I found that by plugging 0 in for x, and so the only thing that was left over was negative 12. And the x-intercept I found using the 0 feature on the calculator. The x-intercept could mean that at year 3 of them tracking, the population actually started growing. Because before that, if you were to zoom in a little bit, you'll see that this part of the graph is actually below the x-axis still. So yeah, you can't have negative population, so that would be what that x-intercept could mean. For number 4, these were the data points that I was able to pull off of this paragraph. You start first week with $200 in the bank. Over 5 weeks, he earns or gets another $1,000, so now he has $1,200. Then the next week, his car breaks down, and he has to spend $800 to get it fixed, so now he's down to $400. But at the end of 18 weeks, he wants to have $8,500. So when you plot these points, and this one I was actually going to walk through with you, you would go to your stat, if you choose to do it this way. Whoops. Clear. I'm going to put in 0, 5, 6, and 18. And then 200, 1,200, 400, and 8,500. Then I'm going to go ahead. I've already turned on my stat plot. So I'm going to go to zoom, stat. Whoops. Okay, now I'm going to go to zoom, stat. Okay, so you can kind of see that. So you notice you start low, then it comes up a little bit, dips down, and then shoots up way up here. Well, even though it's not a nice little graph there, it does follow a cubic type pattern because it's not like a curve or U-shaped curve. It has some loops going on. So when I go to stat, I'm going to select my cubic regression, L1, L2, and you get that function there. So I would plug in 15.56 for A, that number for B, that number for C, and that number for D, and go from there. So write an equation that roughly represents the scenario. That would be the scenario, and then I would just draw the graph that it makes, or plot these points and then connect them with a curve. That would be a rough sketch. What they mean, the key features, you'd have to talk about what those key features mean, such as what does the max mean, what does the min mean, what does your x mean here, what is your y, so your x here is weeks, your y here is money. Oh, yeah, and label the axes. So you'd want to label the axes. Okay, let's go to the next one. Number 5 should look like that. Yeah, for this one, I'm pretty sure everybody has this one down pretty well. So I'm not going to spend a lot of time on this. I'm just leaving it there for you to check it. And then number 6, that's what you should have for number 6. I pulled out the vertex as -2, 7. That's my h and my k. Just picked another point. I happen to pick that one. That's the point, my x, my y I'm going to use. Then I use the standard form for an absolute value, plug in h, k, x, and y, and solve for a. My a here ends up being -2/3, and then my answer is writing the equation that way. And I did describe the transformations like it asked me to. Okay, flip. Okay, this was the graph that was on the board, the function that was on the board. So that should be the graph that you have. Or a rough sketch to that. Make sure that you're watching your cutoffs. I'm pretty confident that everybody in class can graph lines very well. So the thing here that you need to watch out for is making sure that you can draw this graph, and like where one graph ends, you can vertically jump up or down to the next graph, follow that until you have to leave it, and jump vertically up, and you should be able to catch the next graph. You shouldn't backtrack. It should pass the VLT. You shouldn't have one graph laying on top of another. All that stuff is good to check. Number 8 looks like that. You'll notice all this work down here. This work here is what I did to find the equation for that. Since I didn't have enough boxes to really count up and figure out what my y-intercept was, I just chose these 2 points that they gave me and stack and subtract, find the slope, and then write the equation. Okay, so that work gives me that. And I could see the cutoff point was at -5. This last one is based off this graph, and again, I took these 2 points, stacked and subtracted them, and then did the work there to find the equation of the line. So I'll let you check that over. Okay, and flipper. Number 9, that should be your work. Stack and subtract, plug it into the point slope form. Make sure you leave your answer in slope intercept form. This is my fraction work to add 15/8 and 8/1 together. I had to change the 8/1 to 64/8. Okay, number 10 should look like that. I let 0 equal 2008, so my 2 data points were 0, 2.5, and 3, 12.3. Divided, and got 3.267 as my slope. Plug that in. There's my equation. And then it asked me if this trend continues, how many Barbies will she have when she's 18, so I plugged 18 in. In this case it works because it's 18 years after when she was born. And when she's 18, if that trend continues, she's going to have 61.3 Barbies, and my life is going to be taken over by plastic dolls. But hopefully she gets over it by then. Okay, flip, last page. Okay, that should be your work for number 12. When you plot, the thing that you need to remember to do is don't assume that this is linear, don't assume it's a quadratic. You have to do the stat plot. Turn that stat plot on, and then go to zoom and zoom stat to have the points come up so that you can verify the right regression equation to use. Like in that example before, we had to use cubic regression. You wouldn't know that unless you graph the points to see the pattern. Number 13 ends up when you graph the points that you have a quadratic. So that should be your equation for the quadratic. The two things that I didn't do but that you would have to make sure that you can do is you have to describe a real-life scenario that would be modeled like by this function. So maybe one, since this is a parabola that opens down, I might say it models the path of a football flying through the air. And so explain what x and y would represent in that scenario. Well, if my path, well, let me draw a picture. If my path looks like that, then maybe my x-axis is horizontal distance, covered. Maybe my y-axis is height. Then also maybe I can make my x-axis time, and that would be working too, but you have to identify what x and y could or would represent in whatever scenario you pick. Okay, I think that's it. So what I would do tonight is go through this test review. Your test is going to look very similar to this, where you might have 1 to 2, maybe even 3 problems per standard. Well, actually, you might just have 2 problems per standard, a 3 type where if you ace this, you're going to be proficient. But I probably will give you more than one look at it. So you might have 3 problems per some of the standards. Some of the standards you won't. But it'll look very similar to this. So, all right, go ahead and we're done.